हेलो स्टूडेंट्स, आज जैसे अपना नेक्स्ट टॉपिक स्टार्ट करने जा रहे हैं दैट इज बेस्ड ऑन वेक्टर्स। टॉपिक इज डॉट प्रोडक्ट। इट इज आल्सो कॉल्ड एज स्केलर प्रोडक्ट और स्केलर प्रोडक्ट ऑफ टू वेक्टर्स। Within this topic, I will cover the definition as well as the properties of this topic. First of all, meaning. So, it is the product of magnitude of one vector with the magnitude of component of other vector along its direction, or in other words, we will say that the product of the vector and the cosine component of the other vector. चलो डेफिनेशन इस तरह जल्दी समझ नहीं आता। मान लो कि मेरे को एक वेक्टर है ए वेक्टर दैट इज अलोंग दिस डायरेक्शन, और एक और वेक्टर है मेरे को बी वेक्टर दैट इज इन दिस डायरेक्शन। बट नो डाउट इस मैग्नीट्यूड ऑफ ए वेक्टर इस द मैग्नीट्यूड मैं ए लिखागा और मैग्नीट्यूड ऑफ बी वेक्टर मैं बी लिखागा, और इन दोनों के विचकार मान लो कि एंगल है थीटा, एंगल है थीटा, देन दिस बी विल हैव टू कंपोनेंट्स, one perpendicular and one along the direction of this. So the component of b vector along a vector will be b cos theta, will be b cos theta। ਆਪਾਂ ਇਸ ਚੀਜ਼ ਨੂੰ ऑलरेडी रिजोल्यूशन ऑफ वैक्टर्स इन टू कंपोनेंट्स पढ़ चुके हैं। तो कोई वैक्टर होवे उसके कोल दो कंपोनेंट होंगे ने, एक अलोंग दिस, तो अलोंग द हॉरिजॉन्टल दैट इज b cos theta and एक वर्टिकल दैट इज b sin theta। So now this statement says that the product of magnitude of the vector, product of a vector and the magnitude of component of other vector along its directions, इस वेक्टर का जो कंपोनेंट है b cos theta ना दोनों का प्रोडक्ट। सो बेटे इन्हें लिखना है इस तरह, इट इज सिंबलाइज्ड लाइक दिस a vector dot b vector, so it is equal to a b cos theta। सो बेटे क्योंकि ये दोनों ही आ भी मैग्नीट्यूड है, भी मैग्नीट्यूड है, it has no direction, so that's why it is called as scalar product। in the symbol I am using dot, so that's why it is called as dot product। so a vector dot b vector is equal to ab cos theta। so आ हो गई दी डेफिनेशन। प्लीज एज इट इज तुसी ਇਹਦੇ नोट्स बना लेने हैं। आई होप दैट तुसी इसको नोट कर लिया। नाउ आई विल टॉक अबाउट इट्स प्रॉपर्टीज। So its properties now, or you can say that some notes on this। The first point is but a vector dot b vector, this is equal to b vector dot a vector। So we will say that the dot product is commutative। a vector dot b plus c, so this will be equal to a vector dot b vector plus a vector dot c vector। This is called as distributive। So dot product commutative भी है, डिस्ट्रीब्यूटिव भी है। Third, A vector dot A vector. So the angle between A and A will be 0. So it will be equal to A multiply A cos 0. So this is equal to A square. This is equal to A square. So I have already mentioned that A is the magnitude of A vector. So A dot A is taken as A square. Similarly, using this now, I dot I cap dot I cap. So magnitude of I cap is 1. Magnitude of this I cap is also 1. And the angle between these two is also 0. So 1 multiply cos 0. So cos 0 is 1. So therefore its answer is 1. So I dot I is 1. Similarly, j cap dot j cap is also equal to 1. K cap dot k cap is also equal to 1. Based on this thing, I am mentioning the fifth property. But j I cap dot j cap, I cap dot j cap. So I cap is along the x-axis and j cap is along y-axis. So the angle between these two is 90 degree. So magnitude of both is 1. So 1 multiply cos 90. Cos 90. So cos 90 is 0. Product of these two will be equal to 0. Similarly, j dot k is also equal to 0. K dot I. K cap dot I cap is also equal to 0. Now next thing. So please make a note of these things. Next. Sixth point. But if it is given as A vector plus B vector whole square. So then we can write this as A plus B dot A plus B. Now if I open the bracket, so what I will get? So I will get is A vector dot A vector plus A vector dot B vector plus B vector dot A vector plus B vector dot B vector. So A dot A is A square. We know that A dot B is equal to B dot A. दोनों बराबर है. So A dot B plus A dot B. So this can be written as twice of A dot B plus B. So A vector plus B vector whole square can be written as this. So same here formula A plus B the whole square this use कर रहे हो. So that is A square plus 2AB plus B square. So the AB की जगह दे A dot B आना है. इसमें नोट कर ले. Next, but if A vector is given as this, A vector is equal to A1 I cap plus A2 J cap plus A3 K cap. If some A vector is given as this and B vector is given as this, B1 I cap plus B2 J cap plus B3 K cap. So then I want to find A dot B. So A dot B will be equal to, but in this case, this A1 will be multiplied to all. A1 B1 I square, A1 B2 IJ. I dot j is 0, I dot k is also 0. So the product of this with these two will be equal to 0. Similarly, the product of j with I and k will be 0. Product of this and this will remain. Similarly, the product of this with I and j will be 0. So this will remain. So overall ਇਹਨਾਂ ਦਾ ਜਿਹੜਾ result ਆਏਗਾ, so that will be equal to a1 b1 plus a2 b2 plus a3 b3। और ਆ ਬਹੁਤ ਇੰਪੋਰਟੈਂਟ ਹੈ, ਅੱਗੇ ਚੱਲ ਕੇ ਤੁਹਾਨੂੰ ਬਹੁਤ ਸਾਰੇ ਕੁਐਸਚਨਸ ਇਹਦੀ ਲੋੜ ਪੈਣੀ ਹੈ। ਸੋ a ਡਾਟ b is equal to a1 b1 plus a2 b2 plus a3 b3। तो कुल मिला के ਕੀ ਕੀਤਾ, i ਵਾਲੀ ਨੂੰ i ਵਾਲੀ ਨਾਲ ਮਲਟੀਪਲਾਈ ਕਰ ਦੇਣਾ ਹੈ, j ਵਾਲੀ ਨੂੰ j ਵਾਲੇ ਦੇ ਨਾਲ, ਤੇ k ਨੂੰ k ਵਾਲੇ। ਫਿਰ ਇਹਨਾਂ ਨੂੰ ਤੁਸੀਂ ਮਲਟੀਪਲਾਈ ਕਰ ਦਿਓ, ਤੁਹਾਨੂੰ ਰਿਜ਼ਲਟਸ ਮਿਲ ਜਾਣਗੇ। ਨੈਕਸਟ, ਜਿਹੜੇ ਆਪਾਂ ਇਹਨੂੰ ਡਾਟ ਪ੍ਰੋਡਕਟ ਨੂੰ ਯੂਜ਼ ਕਿੱਥੇ ਕਰਨਾ ਹੈ, ਜਿਹੜੇ ਡਾਟ ਪ੍ਰੋਡਕਟ ਨੂੰ ਅਸੀਂ ਯੂਜ਼ ਕਰ ਸਕਦੇ ਹਾਂ ਟੂ ਫਾਈਂਡ ਦਾ ਐਂਗਲ ਬਿਟਵੀਨ ਟੂ ਵੈਕਟਰਸ, ਟੂ ਫਾਈਂਡ angle between two vectors, angle between two vectors। So we know that a dot b is equal to ab cos theta। So from here we can find the value of cos theta। So cos theta is equal to a dot b over a b। So where ab is the magnitude of a and b is the magnitude of b। So here if I have a vector is equal to a1 I cap plus a2 j cap plus a3 k cap, and b vector is equal to b1 I cap plus b2 j cap plus b3 k cap, then we know that a dot b, in the last topic I have discussed, a dot b is a1 b1 plus a2 b2 plus a3 b3। Similarly mod a, so a or mod a, I have already mentioned this in the starting of the lecture, mod a is taken as a, so a will be equal to square root of a1 square plus a2 square plus a3 square। सो ਆਪਾਂ ਇਹਨਾਂ ਦਾ ਸਾਰਿਆਂ ਦਾ ਸਕੁਆਇਰ ਅੰਡਰ ਰੂਟ ਕਰ ਦਿੰਦੇ ਹਾਂ, ਇਹਦਾ ਸਕੁਆਇਰ ਇਹਦਾ ਸਕੁਆਇਰ ਇਹਦਾ ਸਕੁਆਇਰ ਪਲਸ ਕਰਕੇ ਤੇ ਸਾਰਿਆਂ ਦਾ ਕੀ ਕਰ ਦੇਣਾ ਹੈ, ਸਕੁਆਇਰ ਰੂਟ। Similarly b will be equal to root of b1 square plus b2 square plus b3 square। By using all these values in this, what I will get is cos theta is equal to, cos theta is a1 b1 plus a2 b2 plus a3 b3 over root of a1 square plus a2 square plus a3 square multiply root of b1 square plus b2 square plus b3 square। So dot product can be used to find the angle between two vectors। So from here I will get the value of cos theta, then theta will be equal to cos inverse of this। So by getting the value you can find the angle। I hope that you have already made the note of this। Next, it is also used to find some value of some unknown where the two vectors will be perpendicular। So for two perpendicular vectors, for two perpendicular vectors, so perpendicular means theta will be equal to 90। So ਜੇ ਦੋ ਵੈਕਟਰਸ perpendicular ਨੇ ਆਪਸ ਦੇ ਵਿੱਚ, ਸੋ ਬੇਟੇ ਉਹਨਾਂ ਦਾ ਡਾਟ ਪ੍ਰੋਡਕਟ ਕੀ ਹੋਏਗਾ, 0। a dot b will be equal to 0 and this will be used at many places। तो ਅਸੀਂ already ਲਿਖਿਆ ਸੀਗਾ a1 b1 plus a2 b2 plus a3 b3 is equal to 0। So this thing can be used। Next is, it is also used to find the projection of vector a। A vector on B vector. So this can be this is given as our formula है उसे note कर लो A dot B over mod B. Similarly, projection of B vector on A vector. So B vector on A vector projection will be equal to A dot B over mod A. So this is how you can find the projection of the vector on the other. Projection of A vector on B vector and projection of B vector on A vector. So these all are the things that will be required to solve some of the numericals in this chapter. So with this, I close for this dot product or scalar product. Yes, some other places, some other formulas are also there in which we will be using dot product. So examples where this dot product is used. Some examples. Today we have already seen the work done. Work done is the dot product of force with displacement, F dot S. Similarly, power. Power is given as force dot velocity. So the dot product of the force with the velocity is given by this. These are the two places where this dot product will be used. Some other formulas will also be there that we will discuss in our other lectures. So please make a note of all these things. Thank you. Have a nice day.